you have two angles in the included side of two different triangles, then you can use it. So you would mark this picture. You have A, you have an angle, you have a side, and you have an angle. If you mark these little letters, it usually helps us figure out which theorem to use. On the other triangle, I have this angle, that side, and this angle. So if you look at the order, it's ASA, because the side is in between the two angles. The other theorem we're talking about is angle, angle, side. It's the non-included side, meaning the side can be outside of the two angles. So you have this angle, that one, and then that side that's outside of those. I would highly encourage you, when you have a diagram, to mark these little letters so you know which pieces you have congruent, because it helps you, hopefully, when you go to, like, which ones can I use? This is angle, angle, side, because of the order of the letters. The first three examples today, you can use any of these four: side, 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 angle, side, angle, or angle, angle, side, to prove them congruent. Okay. I need you to look at this picture, and please talk to people at your table and speak to them with words. There's a freebie in this diagram. What is it? And so what's congruent? These two in the middle are congruent because they're vertical angles. So this is where I would, to help myself, like, label what I have. I have on this triangle on the left, you have this side and these two angles. The triangle on the right, those two angles in that side. I might do this so it's easier. Look at the order that the letters are written in. Aiden, which one should we use? Yep, angle, angle, side, because the side is outside of those. So yes, they are congruent because of angle, angle, side. It's the same freebie as last time. Thanks, Dalton. Yes, they have vertical angles in the middle. Cool. These marks on the ends, these mean parallel is not congruent. If you have parallel lines, look at your gold sheet right now. You have parallel lines. Then what are we gonna look for? Ethan, what are we looking for if we have parallel lines? Alternate interior angles. Yep. You have actually two sets. You have these two are alternate interior. And then because those transversals are crisscrossing in the middle, you actually have another set. These ones in the corner up here. You have to mark them differently. So notice how I marked the blue ones with 2 and the red ones with 3. Mark what you have on both triangles. You have 3 angles in the left triangle. You have 3 angles congruent on the right triangle. On the triangle on the right. So you have AAA. Does not work. You have to have a side to make it work. You don't have a side. So you should say no. Because angle, 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 you can like cross it out. That does not work. Vertical angles, mark them. These ones. You also have parallel lines. So we know that when we have parallel lines, Allison, what are we going to use? When we have parallel lines. Alternate interior, you have these two. And these ones. On these triangles, I would mark all the pieces I have congruent. You actually have all 3 angles. And you have this side. same thing happens over here. This step's not required, it's just helpful. Emma, what's one way I could prove them congruent? Yep. So this one. Okay. What's the other way? ASA. You see it here. Either one of those would work because you have all the three angles and you do have a side as well. Mm-hmm. Okay. You are proving that triangles ABE, triangle ABE is congruent to triangle EDA. This one is kind of confusing because you are talking about triangles that actually overlap each other. You can write down your givens yourself, so I'm going to draw this in the picture. You're talking about this blue triangle. We want that triangle to be congruent to the one that I'm going to outline in red right now. So we're trying to prove that those two triangles that overlap each other are congruent. Right now, you have an angle, two angles for both. The blue ones have B and then BEAE, or BEA. And then the red one has these two. You have to have a side to make this work. Look at your picture. Is there anywhere you can get a side to be congruent on these triangles? So this side at the bottom is shared. I'm going to mark it with an S so you know that we have that side. Or you can mark it like both of them have this side. Okay? Write that in your proof that we have a reflexive side. So AE is congruent to AE or EA because of reflexive. And now you should be able to prove the triangle is congruent, but you got to be careful and make sure you choose the right one. It's either ASA or AAS, so angle, side, angle, 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 side. It looks like angle, side, angle, right? Because you see this. It's not. What is going on?
That is so stupid.
Stop. Get rid of that. Oh no.
Why would it be right there if there was an angle side angle? And it's so dumb.
He's trying to trick you.
I know. That's why I
Okay,
don't like that.
look at the
That's why I
letters
don't like that.
and how we color coded it. The red ones, you have the two angles, and then the side is outside of it. The blue ones, you have the two blue angles, and then the side is outside of it. So this is angle, angle, side. Because the triangles are overlapping, that side at the bottom is not in between the two angles because the angles are on different triangles. So write down your congruence. It should be AAS on this one. Okay, looking at your picture, you have parallel lines. Justin, look at your gold sheet. When you have parallel lines, what kind of angles do we want?
The alternate interior angle.
Yes, alternate interior, which you have only one set of.
Yeah, I
It's only these two, the lines, the angles that touch the transversal. Make sure you mark them with 2 arcs because you already have angles marked with 1 arc. So I'm going to call them angles 1 and 2. In your proof, you can say that 1's congruent to 2 because they're alternate interior. And you have 2 angles, you still need a side. Mac, where do you think we can get a side?
Probably the middle one.
This one in the middle, your reflexive shared side. So you can say that DB is congruent to itself. Hopefully you wrote smaller than I did because I'm running out of room. You have everything you need now. So I would, to help myself out, I would go to my picture and I would maybe mark little A's and little S's so I can see how it's congruent. The bottom triangle, you have ASA. On the top one, you have ASA. Kyle, what do I use to say they're congruent? Should I use angle? Yeah. Because look, Kyle, look at the picture. See how the letters are marked? ASA. They're in that order, so that's what I use. Say that they're congruent because of ASA. Hopefully you save some room. And then last one would be step 4 is ASA. Okay, you're told that things are parallel. You're told that they're parallel. Is the parallelness marked in the picture yet? No. So you need to mark that AB is parallel to DE, and we do that with little arrows. Let's deal with midpoint first. Look at your gold sheet. When I have a midpoint, then Matt, what should I say is true because C is in the midpoint of BD? That these two pieces, BC and CD, since it's in the middle of those of BD, it cuts that segment in half. So you should say that BC is congruent to DC. Because what is our reason? Definition of a midpoint. So you have a side, you have parallel lines. So Liberty, what kind of angles am I going to use since I have parallel lines? And you can label them. Let's label them. We'll label these 1 and 2. Those are congruent. Because you have transversals that are crisscrossing each other. You have another set. You need to label them differently, like 3 and 4. And you can say that both sets are congruent to each other. 1's congruent to 2, and 3's congruent to 4. Okay. Angle 1's congruent to angle 2. Angle 3 is congruent to angle 4. both of those or because they are alternate interior angles? Look at your picture and please be careful when you look at it. We can mark those letters, the parts that we have congruent to help us. Right now you have, on that top triangle, you have 2 angles and a side. On the bottom triangle, you have 2 angles and a side. Logan, what should I use?
AAS.
Yep, angle, angle, side. Look at this picture. Can you get a different set, like another set of angles?
Yes.
Vertical angles. You could also use the vertical angles, and if you do that, then you could use angle, side, angle. We didn't do that, so we're going to use angle, angle, side. But you could, so if you did that, then that's an option. You do not have big ideas math today.
But we do have to.
So make sure these proofs are done.